Dzień dobry, bună ziua. Hello, I'm Felix, a first-year PhD student at the University of York in the UK, and I'm studying Constraint Satisfaction Problems. In April 1970, a catastrophic explosion on board Apollo 13 led to critical loss of oxygen and fuel. It meant that the crew and ground control had to design a sequence of actions that would help them get back to Earth safely without blowing their electrical circuits or asphyxiating. Such extreme planning is just one example of constraint satisfaction problems. Other applications include timetabling, logistics, and the design of manufacturing processes. More formally, CSPs can be expressed as a set of variables and a set of constraints for subsets of those variables. The idea is to find values for these variables so that all the constraints are satisfied. Here is an example of how we can model the classic Sudoku puzzle as a CSP. One way to solve problems of this kind is to translate or encode them into a SAT problem. The Boolean SATisfiability problem can be thought of as the most basic CSP. All the variables are Boolean, and the constraints are expressed with logical operators, so not, and or. This approach has been very successful for some problem types. In fact, the winner of last year's constraint solving competition used a SAT solver as its back end. There are many schemes for encoding CSPs into SAT, and the choice of scheme for a problem instance can make a big difference in the solving time. Some very interesting work has been done in creating encodings for particular constraints in CSPs. We've already talked about the all different constraint in Sudoku, where each variable needed to take a distinct value. Another example of a constraint is the knapsack, where we have a store of items and each item has a value and a weight, and the challenge is to fill the knapsack without exceeding its capacity, but to reach a certain value or indeed to optimize its value. My research is asking whether it is worth making separate encoding choices for each constraint within a CSP, rather than simply choosing one encoding scheme for each type of constraint. Some initial experiments have shown that the best encoding choice can change as we alter features of the problem instance. Here, these experiments were with a knapsack or pseudo-Boolean constraint. To summarize, the thrust of my research project is to improve the performance of constraint solving by using machine learning techniques to select encodings on a more fine-grained level, at the level of individual constraints. My hope is that this summer school will help me build a viable and competitive system. Thank you for watching, and do get in touch if you want to chat more about this field.